So the next trend we're going to look at is ionization energy. Ionization energy is the amount of energy required to completely remove an electron from a gaseous atom. So if you have an atom that's a gas or an atom that's not a gas, you could superheat it until it's a gas. Experimentally, scientists can determine how much energy it takes to remove an electron from a valence shell. If you remove one electron, that would make it a 1+ ion. So the energy required to remove only the first electron is what we're concerned with in this course. That's called the first ionization energy. So let's talk about what factors determine ionization energy. Well, the same factors that determine any of the periodic trends we're talking about. One is the nuclear charge. The greater the nuclear charge, the greater the ionization energy. The other is distance from the nucleus, or numbers of shells. If you have a greater distance from the nucleus, you have a lower ionization energy. There are some exceptions at filled and half-filled orbitals, so achieving them is easier, which would give them a lower ionization energy. Also the shielding effect. The greater the shielding effect you have, the lower the ionization energy you'll have. So first let's talk about shielding. The electron in the outermost energy level has to look through all the other energy levels to see the nucleus. Let me show you what I'm talking about here. So if this is a nucleus, let's say of a hydrogen atom would have one shell with one valence electron. Now that valence electron is very close to the pulling power of the protons in the nucleus. So it's influencing that electron quite heavily. But if I were to add more shells, let's say 5 shells, it would then be rubidium. Rubidium also has one valence electron in its 5th shell. And it has 4 other shells in the way between that valence electron and the nucleus. But they're not just shells, there's electrons in the way. All of those electrons in the way are shielding or blocking the attractive force from the nucleus. There's 36 other electrons that are going to be pulled on first by those protons in the nucleus before they pull on that 37th electron in that very last shell. So the more shells an atom has, the greater the shielding effect it has. All right, now let's look at some of the group trends for ionization energy. So as you go down a group, the first ionization energy decreases because the electrons are further away from the attraction of the nucleus. So hydrogen only has one shell, and as we go down the group, we add a shell every single time. So francium, which has 7 shells, has more electrons in the way, so it's a greater shielding effect, and also that last electron is further away from the attractive forces in the nucleus. Okay, so let's look at the period trends. So all the atoms are in the same period, so that means they have the same energy level. We're looking at period 4 here. So the atoms in period 4 have 4 shells. So that means they have the exact same amount of shielding. But as we go across period 4, an increasing nuclear charge, we have more protons. So krypton has 35 protons. It has a pulling power of 35, which is stronger than something on the left, like potassium, which only has a pulling power of 19. So ionization energy is going to increase from left to right. The stronger those protons pull on the electrons, the more energy you would have to use to remove one and turn it into a +1 ion. There are some exceptions at full and half-full orbitals, but again, I'm not testing you on the exceptions, I'm testing you on the general trends here. So remember, as you go down a group, the first ionization energy gets smaller because each element has more shells. The valence electron is further away from the pulling power of the nucleus, and also there's more shielding, which is going to be blocking the pull of the protons, which will again lower that first ionization energy. As you go across the period, first ionization energy gets bigger because each element has more positive protons to pull those negative electrons in harder. Therefore, you need to use more energy to remove one.